Hi and Assalamualaikum. My name is NURFATIN AQILAH binti ADLI MURAD. My ID number is 2020862188. Today I want to present spatial and geostatistical analysis. Objective. First, to learn technique to buffer and overlay from spatial data. Second, to understand the function of spatial analysis. Third, to understand how to merge two or more feature classes, which is vector files or raster file, into a single feature class or raster dataset. Fourth, to understand fundamental GIS using ArcGIS. Next, to familiarize component in ArcGIS. Lastly, to recognize geospatial data. Methodology: spatial analysis. Okay, we insert the derive and we can see it appear in the map. Okay, next we go to the art toolbox, choose the analysis tools and they choose the proximity and choose the buffer. And then input, we choose the derive. So for the output, we need save in the same folder. The output we rename as derive underscore buffer underscore 300 and then click OK. For the linear, we change to 300 in meter and the dissolve type is all, and then we click OK and we wait for a while for the buffer. The buffer will appear. We redo the same step for the buffer 9. Follow the same step only. The soft type we will change to the 9, and for the output we will choose the buffer underscore 300 underscore 9. After the buffer 9 was appear, we can zoom in and zoom out to see the difference between buffer dissolve all and dissolve none. And next, we add district Kelantan to the arc map. For the next analysis we do is erase. For the input feature, we choose the derive underscore buffer 300. For the erase feature, we choose the derive. And for the output, we rename is derive erase. After that, we click OK. After the erase was appear, we do the union. The input feature district Kelantan and derive buffer 300. And for the output, we save as derive district union. And then we click OK. After the union was appear, we open the open table for the district Kelantan and derive, and we see the difference. The last overlay we do is intersect. For the input feature, we choose the derive and district Kelantan. And for the output feature class, we put derive underscore intersect. And then we click OK. And we wait for a while to look the intersect will appear. And then we change the color for the intersect to look more clear between the district of Kelantan and derive. And then we also can see the attribute table to see the intersect happen. So that's all for module 3 part 1. Thank you. Methodology: geostatistical analysis. For geostatistical analysis, first we open the new arc map and then we insert the daerah. After that, we open the arc toolbox. Then we choose the conversion tools, choose the SL, and lastly choose SL to table. The input we choose is data ground underscore 1 July 2015, and after that we press OK. Then data ground will appear at table of content. Next, go to the data ground SL, right click and choose the display SY data. S field as E, Y field as N, then press OK. The point will appear. And then go to the data ground just now, choose the data and then export the data. We save data as PM10. After the PM10 appear, we will remove the SL of data ground. For the next step, we go to the customize, choose the extension, then we tick at the geostatistical analysis. For the next step, we go to the geostatistical analysis. For the input data, we choose PM10 at data field and then finish. Next, we right click at the layer and choose the properties. At the data frame, extend used by full extend command, we change to others. And then choose the outline of feature as daerah. So for the clip option, we choose clip to shape and specify. Shape as outline of feature, we choose the daerah. And then we press OK. Next, go to the inverse distance weighting, right click and choose the properties. And then the extent we choose as the rectangular extent of the daerah. And then we click OK. Next step, go to PM10, right click, choose the properties, we change the label. We tick label feature in this layer and then press OK. For the daerah, we change to the hollow color. After that, we sort table of content. Next, we will do another analysis, which is the cringing. The data field we change to the PM10, then press next, then we press OK. The cringing has appeared. Then go to the cringing layer, choose the properties. Then change the extent to the rectangular extent of the daerah. And then we press OK. So we finish the second part, which is geostatistical analysis. Thank you. Practical highlight. Spatial analysis. Discuss how do the result differ between dissolve all and the dissolve none in buffering. So for the dissolve all, the product shows buffer of individual data combined into the single feature. And for dissolve none, in the end the result show buffer of individual data being constant and differentiate. The product are separate in their features. Second question. Screen capture each overlay analysis done and explain the overlay feature. For the buffer, it is a reclassification based on the distance, classification of within or without given proximity. It involves the measuring distance outward in the direction of an object. For the erase, the feature to be used to erase coincident features in this output. It creates a feature class by overlaying the input feature with the erased feature. Next, for the union, it will combine features from different layers into a single composite layer, preserving the boundaries and attributes from all the input features. When the features overlap, it will create separation for them. And lastly, for the intersect, it calculates the geometry intersection of any number of feature classes and feature layers. The feature or the portion of feature that are Third question. How is the SY tolerance defined in the intersect dialog? How many records does final.shp have? So, SY tolerance refers to the minimum distance between the coordinates before they are considered equal. In the intersect dialog, the SY tolerance is left blank. It shows that it imposed under the default setting. And for the final record, there were 343 records at the end of district intersect. Next question. Highlight all spatial analysis performed in this practical and relates the function of each analysis with real application in environment context. First is buffering. It involves measuring distance outward in the direction of the object. It can be done on all three types of vector data, which are point, line, and polygon. For this analysis, the result buffer in a line. Buffering around line creates a series of elongated buffer zones around each line segment. For the example, since traffic increased, the town planners went to widen the main road and added a second lane. Therefore, the buffer is created around the road to find the properties that fall within the buffer zone. Next analysis is overlay. It is settled by joining and viewing together separate datasets that share all of part of the same area. It is often used in conjunction with other types of analysis such as buffer tool or aspect tool. For the example, the site of nuclear waste repository, it must follow the requirement, such as it must be in area with acceptable geology, it must not be easy to accessible, it must be far from the densely populated area, and it must be outside of the concentration area. Next part is geostatistical analysis. For the first question, you have tried several types of transportation method. Screen capture the output and explain based on your observation the difference between all the methods. For the inverse distance weighting, we can see its determinate method, which is the mathematical data. It an interpolated approach that demonstrates the relationship between distance and weight regarding spatial data. It has bull's-eye effect more, and it is sensitive to outliers and sampling configuration. So for cleaning, it is a geostatistical method. It also is mathematical and statistical data. A method of interpretation that displays the relationship between distance, direction, and statistical data and geographic data. It is more computationally intensive. Last question. Summarize the use of geostatistical analysis used in the practical and environment study. For the inverse distance weighting, it is to estimate the value of any unmeasured site in this analysis. In the inverse distance weighting, the measured values surrounding the forecast site are used. For the example, it can be used to determine the concentration of particulate matter 10 in air quality index prediction from the measurement of 5 meteorological stations adjacent to the study area in the Selangor. For the cleaning, variograms are used in a statistical method to quantify the spatial autocorrelation between location at a graduate distance. It is appropriate for use in soil science and ecology. For example, cleaning was used to determine the topsoil analysis of e-waste recycling site in Canberra Highland, as it performed better for the spatial Conclusion. For this module, we learned the technique of buffering and overlay for spatial data. We also dominate the function of spatial analysis and how to merge two or more feature classes which are vectorified or rastrified into a single feature class. And lastly, from this module, we recognized the geospatial data and became familiar with the component in ArcGIS, especially in the toolbox, which was a buffer, union, intersect, and erase.